Hello everyone! In a recent video, we introduced this workflow for streaming tweets from the Twitter API and storing them in persistent storage via a Google Cloud Platform BigQuery table. This orange squiggly line separates what we did in the last video from what we're going to do in this video. So we essentially were able to write a Python script that ran locally to use the TweetPy library to stream the tweets from a few different usernames. When we received a tweet, we were able to publish that tweet as a message to a Google Cloud PubSub topic. We confirmed that the publish worked, but now we need to work on the subscribe side. We need to set up our very first subscriber that will pull messages, and then we need to set up our second subscriber, which will be a cloud function that's triggered whenever a message is published to our topic of interest. That cloud function will have some code that will insert the tweet that was just published and then subscribed to into a BigQuery table. So that's what we need to do. Everything to the right of the orange squiggly line, which includes the subscribe side of PubSub, and inserting our tweets into a BigQuery table for persistent storage. I highly encourage you to watch that recent video that I've mentioned. Also, if you're not familiar with BigQuery, you can watch a video where I use BigQuery as persistent storage for rows that represent tweets that I grab from the most recent 24 hours of tweets from a Twitter account. That's also in a recent video that I've made. All right, let's pick up where we left off in our last video. We were just able to confirm we could publish a tweet as a message to a pub subtopic called tweets. All right, here we go. So here was our original dictionary we printed out. And then here's our dictionary printed out again from line 46. And you can see there's a published result and then there's a result. I like to call this confirmation code. So it looks like this was successful. So let's go back to Google Cloud now. And we're still in PubSub. We're going to go to subscriptions. And there should be a default subscriber created because we left that box checked when we created our topic. Here it is. It's called Tweets Sub. So we'll click it. We'll go to Messages. And we can press Pull in order to view messages that have been published to this topic that have not yet been pulled by the subscriber. So there's pulling subscribers and there are pushing or triggering subscribers. This one is a pulling subscriber. So it doesn't get notified or triggered when there's a new message for the topic. Instead, it has to be more proactive and go pull. See, is there a new message? Is there a new message? So let's hit pull and we should see that message that we published to the topic. All right, here it is, publish time. And there's the message body. So it looks like our publish side of PubSub is working with our default subscriber. Now what we want to do is we want to create our own subscriber. So this subscriber is going to be a Google Cloud function. We can make it from the Google Cloud Functions page, or we can make it even more simply from the PubSub page. So if we go back to topics, click on our tweets topic, and then towards the top here, there's a trigger cloud function button. We'll click it. You may be prompted to enable some cloud function related APIs. I've already got these enabled from using the same project in a recent video on cloud functions. So we can leave most of the defaults here. We can give our function a descriptive name, though. Maybe I'll call it tweets topic subscriber cloud function. Next, we're going to go down to the source code and change the runtime from Node.js to Python. Choose whichever version of Python matches what you were testing with locally. For me, that's 3.9. And then the entry point should be called hello PubSub. And we've got this main.py and requirements.txt already stubbed out for us. It looks like this is the interface we have to adhere to when writing a cloud function in Python for a PubSub topic subscriber. So it looks like there's two parameters, event and context. Event is a dictionary with the event payload, and then context is a Google Cloud Functions context metadata for the event. So there's already some starter code here that's going to decode the data, which is the message, from the event dictionary and decode it from UTF-8 into a string and then print the string out. We don't need to modify this too much, except what we want to do in addition to printing out the message to our logs to make sure that everything's working is we want to insert this message as a new row in a BigQuery table. So I'm going to head over to the code that I pre-wrote that will do all of this work for us. So I wrote most of this code in a previous video. I've just adapted it to work with the Cloud PubSub subscriber function interface. So what this is going to do is when this function is triggered, it's going to do the decoding that you just saw, print out a shortened version of the message, and then create a JSON object from the message, which is a string, package that up into a list of one item, and then call my insert rows to BigQuery, which is going to create a BigQuery client, get a dataset reference, get a table reference, and then use that table reference to insert this single row into our BigQuery table. And then if nothing goes wrong, we should see new rows have been added in the logs. If something goes wrong, we should be able to see what the error is. So I'm going to copy this and I'm going to paste this to be the body of main.py. We also need to think about our requirements.txt. So requirements.txt, this is where we specify any non-standard Python packages that we need to be installed for our main.py to run. And here we need to add Google Cloud BigQuery. You can see in main.py at the top, I'm importing that library, so it'll need to be pip installed. Google Cloud -BigQuery. All right, let's hit deploy function. It looks like our cloud function was successfully deployed. Let me head over to BigQuery and show you what the schema looks like for our tweets dataset and our tweets table. So there are 4 fields: tweet ID, author ID, created at, and text. Now to see if our tweet made it into our BigQuery table, we'll run a simple query, select star from tweets dataset.tweets table. And there it is at the very end. Does this make it to BigQuery? So it looks like from Twitter streamer all the way to BigQuery, our workflow is working. The only thing that I'll note is that it's not entirely in the cloud. Recall that this tweet streamer right here, this Python script, is running locally on my machine. The final piece of the puzzle is to take this Python script and get it running up in the cloud. So that's our last thing that we're going to do. So let's go back to console.cloud.google.com again, and this time search for Compute Engine. We're going to spin up a little VM, a free VM, that can run our Python script, logging all of the tweets that it receives by publishing them to PubSub, which will have a subscriber, a cloud function, that'll insert them into BigQuery for persistent storage and use later. With the API enabled, we can now click Create Instance. There are many different types of instances that we can create. They're each subject to different use cases and different charges. What we're going to do is create one that lands us in the free tier. So this will be under the E2 series. And if you expand the E2 series, you should be able to see E2 Micro. I'll mention that it shows the monthly estimate to be $7.11, but you can confirm that this, at the time of recording, this E2 Micro instance is part of the free tier by going to cloud.google.com/free/docs/free-cloud-features, and under Compute Engine you can see one non-preemptible E2 Micro VM instance per month in one of the following US regions. So note that things change all the time, and you should be monitoring your usage and your billing account to make sure that you don't have any surprise charges, and even better yet, set up alerts and hard stops for your budget so that you don't ever get overcharged for something. All right, back to the Compute Engine. We're setting up a new instance, so E2 Micro. We can keep scrolling all the way down and hit Create. Now we can click SSH in order to open an SSH connection to our newly created VM. So what we'll need to do here is we'll need to upload all of the files necessary to run our tweet streamer. That includes main.py, Google keys.json, Twitter keys.json, and we'll need to either install one at a time all of our requirements or create a requirements.txt and upload it, or make it here in the shell so that we have all the dependencies in our Python environment to run that main.py file. So let's go back to our code, and we should have the start of a requirements.txt file here. I'm going to add to it Google Cloud PubSub. Make sure that I save the file. And now I should be able to use this handy upload file feature. And I'm going to upload my files. With the files uploaded, I should be able to see them in my home directory. And now I can install pip. Once I've installed pip, I should be able to install all of the requirements, the requirements.txt, run main.py, and test the whole thing one more time. That took a little while to install, but it went in successfully. So now we can do pip3 install -r and then requirements.txt and install our dependencies. Make sure that you've killed your tweet streamer locally because we're about to launch it in the cloud. One more time, I'm going to make a tweet and see it go through from beginning to end. I just pressed the tweet button. There it is, showing up with our tweet streamer. Published result looks good. It'll make it all the way. We are good to go. All right, we did a lot in these few videos. If you recall, we started with TweetStreamer and TweetPy. We made it all the way over to Compute Engine with a fully automated solution in the cloud that will stream tweets according to filter rules and store those tweets in persistent storage using BigQuery. The central piece that tied this all together was Cloud PubSub. So hopefully you learned a lot and were able to get this running on your machine. Stay tuned for more Google Cloud Platform videos. That's it for today. Thank you for watching.